Bismillahirrahmanirrahim. Assalamu alaikum viewers. You are watching YouTube and Facebook channels of Professor Dr. Rizwan Jamil Qureshi. Welcome to the lecture number 15 of Software Economics course. We were covering COCOMO 2 software cost estimation model and we calculated OP, NOP, effort, project cost. This is the OP, 208 objects. We calculated NOP 62.4. Productivity is 13 NOP. Labor cost is $4,000 per month. So cost per NOP, labor cost divided by productivity, cost per NOP is $308, and project cost per NOP multiplied by NOP of new project. So effort is equal to NOP divided by productivity, 62.4 divided by 13, and that is 5% month. And now we need to calculate time, and that is the time formula: 3 multiplied by effort power 0.33 plus 0.2 multiplied by B minus 1.01, where B is complexity exponent, and we learned in the last lecture how to calculate B. The B value in the exercise is 1.17. So calculate the time: 3 multiplied by 5, B value is 1.17. Calculate time. Time is equal to 3.4 months. So we calculated time. Time is equal to 3.4 months. Now we need to calculate team size. So people formula is effort over time. So people is equal to effort is 5, time is 3.4. So approximately 2 persons. Approximately 2 persons. So we calculated OP, we calculated NOP, we calculated cost per NOP, we calculated project cost, we calculated effort, we calculated time, we calculated team size. This is what we need to start any software project. All parameters of the metric are completed. Let's move to the second exercise. Project has 30 screens, 20 reports and 100 components, and it's an average complexity project, and project has 60% reuse. The developer experience and environment maturity are nominal. $7,000 per month is the labor rate. Calculate OP, NOP, project cost, effort, time and team size. So like exercise number 1, we make a table. Now you have 30 screens, 20 reports, 100 components. It's easy. Complexity factor is 251 for the average complexity project. Calculate the total for number of screens: 60 for screens, for reports 100 and 100. So it is summation of 3 values is equal to 260. OP is equal to 260. Total number of objects for this project 260. Now we need to calculate NOP. So NOP formula is OP multiplied by 100 minus percentage reuse divided by 100. OP is 260 and the reuse we have 60%. Calculate NOP. What is the NOP value? So we have NOP is equal to OP multiplied by 100 minus percentage reuse divided by 100. Reuse is 60%. OP is 260. What is the value of NOP? 60% is the reuse, means it is 40% new development. 260, so it's a 104. Double check your answer. 260 multiplied by 0.4. Is it the same answer? That is what we calculated through the Barry Boehm's formula of COCOMO 2. Now we go back to the exercise. The developer experience and environment maturity are nominal. That means the productivity is based on nominal developer experience and nominal maturity. We go back to our table of Barry Boehm. From this table, if developer experience and environment maturity are nominal, the productivity is 13 NOP per month. So we go to our exercise. Productivity is 13 NOP per month. Labor cost is $7,000 per month. You can calculate cost per NOP. 7,000 divided by 13. So what is the cost per NOP? Calculate cost per NOP. Calculate cost per NOP. Labor cost divided by productivity. Labor cost is 7,000. Productivity is 13 NOP per month. $539. We can write 539. Project cost is equal to cost per NOP multiplied by NOP of new project. Cost per NOP 539. NOP is 104. So calculate the cost. So $56,056. Now we need to calculate effort. Effort is NOP divided by productivity. NOP is 104. Productivity is 13 NOP. So what is the effort? 8 person month. Effort is 8 person month. We need to calculate time. Formula is, and B value, we go to the exercise 1.17. So time is equal to 3 multiplied by effort power 0.33 plus 0.2 multiplied by B minus 1.01, and B is the exponent, value is 1.17. So calculate time, approximately 6.4 months. Approximately 6.4 months. Now we need to calculate people. Effort over time. Effort is 8 and time is 6.4 months. 8 divided by 6.4, approximately 2 persons. So we have time 6.4 months. People, effort over time 8 divided by 6.4, approximately 2 persons. We calculated OP, which is 260, and OP 104, productivity 13, labor cost divided by productivity, labor cost 7,000. So we calculated cost per NOP 7,000 divided by 13, that is $539. Project cost per NOP multiplied by NOP 539 multiplied by 104, $56,056. Effort NOP divided by productivity 104 divided by 13, 8 person a month. So time is 6.4 month. People, effort over time 8 divided by 6.4, we have 2 persons. That is COCOMO 2. Now we move to use case point estimation. Use case point estimation has a formula. How much is the approximate size of the use cases we have? How many use cases we have? And what is the size of each use case in terms of number of lines? How many lines are there in each use case? So summation of the all use case values in terms of number of lines is equal to total size of the use cases in terms of lines of code. So for example, there are 5 use cases. For each use case, what is the approximate size? Summation of the all size is equal to total size of those use cases. So cost per LOC, labor rate divided by productivity. Labor cost divided by productivity is the cost per LOC. Total project cost, LOC, lines of code multiplied by cost per line of code. First exercise, calculate the cost of project if average size of 6 use cases are 9,530 lines, source line of code. Labor cost is $8,000. Average productivity of the company is 620 LOC per person month. So we know total size of the use cases. There are 6 use cases, and total size of 6 use cases is equal to 9,530 lines. We know labor cost, we know productivity, so we can calculate the cost of project. First, we calculate cost per LOC. So we have formula labor cost divided by productivity. Labor cost is $8,000. Productivity is 620 LOC per person month. So what is the cost? Cost per LOC. But dollar always come in front. The rest of the currencies we put after the numbers. But for dollars, we put dollar in front of the numbers, before the numbers. So that is $13. The project cost is, so we have LOC of the 6 use cases, 9530 SLOC. Cost per LOC we know is equal to $13. So project cost is equal to 9530 multiplied by $13. Don't miss the unit. 1,23890 we calculated project cost using use case point method. How we calculated the size? So type of use cases: simple, average, complex. For example, there are 3 simple use cases. Average size of each use case is 560 lines per use case. So 560 multiplied by 3, 1680 total. Average complexity use case 2. Per use case size is 3100. So 3100 multiplied by 2, 6200. For the complex use cases there is 1 and average size is 1650. Summation of the 3 values for average line of code per use case is equal to size of software in LOC, that is 9530. This is the way we calculated the size by using the use case point method. Average size of the use cases is 33,200 line of code. Productivity is 420 LOC per person month. Labor cost is $7,500 per month. Calculate the cost per LOC and the project cost. So cost per LOC, the formula we have labor rate divided by productivity. Labor rate is 7,500. Productivity is 420 LOC per person month. 420. So what is the cost per LOC? Approximately $18. Project cost is cost per LOC multiplied by LOC. So average size is 33,200. LOC is 33,200. Cost per LOC is $18. So 33,200 multiplied by 18. So $597,600. So cost per LOC, labor rate divided by productivity. Labor rate is 7,500. Productivity is 420. So cost per LOC 5,500 divided by 420, $18. Project cost is LOC multiplied by cost per LOC. LOC is 33,200 and cost per LOC $18. 33,200 multiplied by 18. So $597,600 is the project cost. We have Agile budgeting, but before that we start the Agile calculations. There are some Agile concepts I want to clarify, I want to discuss. There are 4 Agile values. Prefer people over processes and tools. People are more important than methodologies, than tools. The people are the main strength that can cause Agile projects successful. But before I discuss values, I would like to discuss agility, because you can understand the concept only once you know the agility. That what kind of people we need, what is agile, what is agility, how to define agility. Agility means respond to changes quickly and efficiently without compromising the quality of software. The quality should not be compromised. Fast doesn't mean you do mistakes, you do blunders. Normally we think if you do too fast, that means you will do more mistakes and there will be more bugs, poor requirements, poor design, poor implementation, poor testing, and there will be lot of bugs, lot of defects, and customer will reject it. But Agile said no, do it fast. So thank you very much. Love you. Take care. Stay blessed, healthy and happy. Assalamu alaikum.